Okay, let's see some examples of how to work examples of normal distribution applications. This applies to both finding probabilities and also finding percentiles. So we have a population here, number of chocolate chips in an 18-ounce bag of Chips Ahoy is approximately normally distributed. So we have a mean of the population of 1,262 and a standard deviation of 118. So we want to find the following probability. So part A, find the probability that a bag, so X is the number of chips, the mean and standard deviation of X. So what's the probability that X is less than 1,200? So let's draw this out. I would strongly recommend always drawing a normal distribution graph. The mean always goes in the middle. And so 1,200, I'm not sure, no, I'll just kind of eyeball it over here. Right. So we're trying to find this area. That area will give us the probability that we're looking for. Okay. So the first thing we have to do is we have to take that 1,200 and convert it into a z-score. So if X are, these are the original scores, the z-scores represent how many standard deviations above and below the mean. So we can take 1,200 and convert that to a z-score. So 1,200, 1,262, again, the formula for z-score, divided by 118. From that, it's negative 62 over 118, and we get about negative 0.53. We're only going to round this to 2 decimal places because the table that we're going to look up these values in only goes to 2 decimal places on the z-score. So there's really no point in any more than that. So that's, if you look back to our distribution, these are the z-scores corresponding with the actual values of X. So what we're trying to find is the z-score, probability of a z-score being less than negative 0.53. So this is where the table comes in. So one thing we have to remember is, I can't draw on this one, but the z-scores, you can see where the hand is going. The z-scores, the ones digit and the first decimal place are in this column, and the second decimal place is in this row. So the z-scores are along the left and top. Everything on the inside, all these numbers starting with 0.50 all the way down to this negative 0.98, those are all areas. So we need to be able to keep that difference in mind. What we're looking for, is a less than negative 0.53. And again, I want to point out, what's happened there? I want to point out that, that the area on this table is to the left. So whatever z-score we look up, the area on the interior of the table is going to be to the area left of that z-score. Now, we have a negative z-score of negative 0.53, and these are the positive z-scores. Okay, so we had some technical difficulties here. The table is up and working. Okay, so we're trying to find the area to the left of a z-score of negative 0.53. So, as I said, the tenths place, the first decimal place is going to be in the left, and the second decimal place is going to be on top. So we go to negative 0.5, that's over here. So where the hand is. and the 0.03, that's going to be the second decimal place. And so what we're looking here is 0.2981. So that is the area 0.2981 to the left of negative 0.53. So 0.2981. Okay, so let's go to part B. So it contains more than 1,500 chips. Okay, so 1,500. So again, we have 1262. Here's 1,500. And now we're trying to find this area. Okay, so the probability, we got to get a z-score bigger than 1,500 minus the mean over the standard deviation. So we have 1,500 minus 1262 divided by 118, and we have 2.02. Okay, so now a z-score greater than 2.02. What I want to point out in the table now is this table gives us areas to the left. What we're looking for is an area to the right of z equals 2.02. So there are a few ways we could do this. If we recall, the standard deviation, the standard normal distribution is symmetric, and the standard normal is symmetric over 0. So let's kind of draw this out here. This is what we're trying to find. This area is what we're trying to find. However, because the standard normal distribution is symmetric around 0, this area and this area are going to be exactly the same. So we could look at this in one of two ways. We can say 1 minus the probability of z less than 2.02, since everything has to add to 1, or we can simply find the probability that z is less than negative 2.02. I prefer the second method because if you can find the value directly from the table, you save the arithmetic, and therefore you save a possible error. So I'm going to go with this second, left of negative 2.02. So with that in mind, negative 2.0, 2.01, 2.02. It's 0.0217. And that's going to be our area. Okay, let's do another one here. Now we're going to find between two values, and this adds on a bit of another step here. Find between two values, so between 1,000 and 1,400. Once again, make our chart. Always make a diagram chart. It applies to any word problem in algebra, and I would apply the same things here. Okay, so again, we have 1262, and we want to find, I'm just going to eyeball this, 1,000 to 1,400. So what we're trying to find is this area in here. What is the area of that? Okay, so what we have to realize before we even go to the z-scores here, remember the z-score gives us area to the left. That's the only thing I can look up in our table. So what we would want to find then is I'm going to find the area to the left of 1,400 We haven't converted these to z-scores yet, so it's still 1400. Subtract the area to the left of 1000. And that will give us the area that's left over the middle. You take this and subtract this, and this is what you're left with. That is exactly what we're trying to find. So let's go ahead and convert those to z-scores. Z is less than 1400 minus 1262 and 118. Okay. So this first one, 1400 minus 1262 divided by 118, and that's 1.17. So minus 262, or 1000 minus 1262, gives us negative 2.22. Okay, so we're going to look up two different areas this time. Left of 1.17 and left of negative 2.22. So let's go back to our table. We're going to go back to the positive z-scores. 1.17, so here's 1.1. 0, 1, 2, again, I'm going the second decimal places up, so this is 1.10, 1.11, 2, 3, 4, 5, 6, 7. So that's 8790. See out here. And then negative 2.22, okay, so that's a negative z-score, so we have to go back to wrong direction. Negative z-scores, negative 2.22, and we get over here, we get 0.0132. Again, the negative 2.2 and the 0.02, so that's 0.0132. All right, let's go back to the actual button text here. So what we're going to have is 0.8790 minus 0.0132. And that adds up to, or subtracts to 0.8658. Okay, that's how you find the area between 2 points, by subtracting two areas from each other. Okay, now we're going to go from finding areas to finding percentiles. So in parts A, B, and C, here's what we did. We got an original value, converted that to a z-score, and looked up the z-score to get an area. Now, what we're going to be doing in the last three parts is we're going to be given an area, find the z-score that gives us that area, and then convert that back to original data. So we're going this the exact reverse process. So, refresh my memory, what is it? It's the 99th percentile. Okay, so a few vocabulary things here. 99th percentile. So what that means, remember back to chapter 3, what that means is it means whatever score this is, so whatever, again, we'll put our z-scores here and our original data back here. So 99th percentile means we want a 99% or 0.99 area to the left of that number, whatever that is. Now, we also have a symbol, a notation for this. Z alpha, and this, we're going to see this when we get into, if you look ahead to the formulas in Chapter 7 and Chapter 8, the formulas will have a Z alpha or a Z alpha over 2 in it. So it's really important to understand where this what this notation means. So this means the Z-score giving area alpha to the right. And that's a very important definition. So Z.01, that's going to be the Z-score that gives us a 0.01 area to the right. Now there are two ways that we can find this. Remember the table, so this is going to be 0.99 area to the left, because the table gives left-hand areas. So remembering that the areas are in the body of the table, well, we don't see anything close to 0.99 here. We're going to have to go to the positive z-scores. And 0.99 as close as we can get is going to be right here, 0.9901. And so we're going to follow that. That's going to be 2.3. And then the second decimal place here, so 2.33. The other way we can find this, and we're going to start using this table by Chapter 7. If we go to Table A3, okay, don't worry about what a t-value is for now. As of Chapter 6, we're not, this is something we're going to look at later on. But for now, all I need you to pay attention to is this last row where it says large. This is the only thing we're paying attention to right now. This allows us to directly look up an area and find the z-score associated with that area. So we're trying to find z.01. And it's going to be 0.01 in that right tail. 0.01 to the right. And so you go to the second column, go all the way down to the large, and this is a little different. This is 2.326. A little more precise. So the 2.3, again, the 2.33 was an estimate based on Table A2, but of course that wasn't exactly, we weren't getting exactly 0.01. That's why there's a slight difference here. Okay, so that's the area we're trying to get. So now let's remember the formula for a z-score, right? The z-score is equal to x minus the mean over the standard deviation. So we know that the mean has a z-score of 0. We know that it's 1262. So this is the z-score, so we need to find what x value that goes with. So x is what we're trying to solve for. We can plug everything else in. So we have 2.326 equals x, that's what we're trying to solve for, minus the mean, that was a 1262. So we're taking the z-score and converting it back into an original data value. Standard deviation, I think that was 118. Yeah. Okay, so once we have that, again, the rest is algebra. We multiply both sides by 118. See, there's some algebra in here. Not a whole lot. This is about as complex as it gets. 2.326 times 118. 274. 0.468, I'll just round to one decimal place, equals x minus 1,262. And so when we add 1262 to both sides, we can even round this off to the number. I'm just going to say 1536, 1,536. This is going to be the 99th percentile. Meaning if you take these 18-ounce bags, about 1% of them will have more than 1,536 chips. The other 99% will have roughly less than that amount.